Hello, today we're going to be discussing synthetic division. It is a nice little shortcut to polynomial long division, but one of the things is you can only divide by a binomial. So we can only divide by a binomial, not a trinomial, anything fourth, fifth degree, that's out of the question. So if you have a binomial that you're dividing by, you can use synthetic division as a major shortcut. You will not be using the factor. Let's say one of my factors was x minus 2. Here my factor is x plus 2. I can divide by this. This is a binomial. But I will not be using this for my division. I need to use the root or the 0 of this. So if I were to set this to 0 and solve, I'm going to end up with x equals negative 2. So on the outside, I will be placing a negative 2 value. Okay, let me slide this up a little bit. Okay, then on the inside, we are going to be using the coefficients of what we are dividing into. X cubed, negative 3x squared, minus 7x, and plus 6. This must be in a standard form, which it is. It is in descending order. We need to fill in any missing terms with 0. We have them all, so we don't need to use any placeholders there. And then we are going to be adding down. Don't subtract, but add when we are doing this. Okay, so I'm going to take these coefficients. I have 1, I have negative 3, I have negative 7, and I have a positive 6. Okay, so the way that you start this off for synthetic division, you are going to bring your first term straight on down right there. So that 1 comes directly down. Then it becomes a multiplication problem. Negative 2 times 1 is negative 2. Then we're going to repeat what we just did. We are going to add down negative 5, then multiply. So negative 2 times negative 5 is a positive 10. Add down 3. Negative 2 times 3 is a negative 6. We will add down, and you end up with 0. This is your remainder spot. So since 0 means no remainder, that means that x plus 2 is a factor. It is a factor. Which leads us to the root of negative 2. So negative 2 is a root slash 0. X plus 2 is a factor. That's what happens when you get a remainder of 0. Now, we divided a binomial, a single x, into an x cubed. So what that means is this would be knocked down 1 degree. So imagine x cubed and dividing an x into it, then you're going to end up with x squared. So coming down here, what you have left with these are the coefficients dropping down a degree. If we were at 3, this will be degree 2, x squared minus 5x positive 3. So when you divide this in, what you have left over in that division problem would be x squared minus 5x plus 3. Okay, let's take a look at a couple more examples. You're going to get mighty quick at using synthetic division with a little bit of practice. So let's say it is x cubed minus 3x squared minus 7x plus 6 divided by x minus 4. So we're going to take this and we need to find the root or the 0 of this factor. So we'd set it to 0 and solve, and you would end up with 4. Now on the inside, we're going to take the coefficient. So I have descending order 3, 2, 1, 0. Great. I don't need to fill in anything, so I can take 1, negative 3, negative 7, and a positive 6. The first term comes straight on down here, 1. Now it's a multiplication. 4 times 1 is 4. Add down 1. 4 times 1 is 4. Add down negative 3. 4 times negative 3, negative 12. Add down negative 6. That is my remainder. It does not go in there evenly. That means that x minus 4 is not a factor. 4 is not a root or a 0. So this division problem ends up being knocked down 1 degree from 3 divided by an x gives me an x squared plus x minus 3. So my answer to this division problem would be x squared plus 1x, excuse me, I forgot that x there, plus x minus 3 with a remainder of negative 6 over what I'm dividing by, x minus 4. Okay, let's take a look at some more here, just kind of moving down the line. Say x cubed minus 14x plus 8 divided by x plus 4. Okay, we're going to take this right here and we need to find the 0 or the root of this factor. So I'm going to set it to 0 and solve, giving me negative 4. Division problem 3. Oh, I'm missing my x squared term. So I will take the coefficient here of 1. I need to fill in a 0 term for my x squared. Now I can deal with my negative 14 and my positive 8. Make sure you have all terms accounted for in descending order, please. First term comes down 1. Multiply. Negative 4 times 1, negative 4. Add down. Multiply. 16. Add down. Multiply. Add down. Remainder of 0. Great. X plus 4 is a root. Excuse me, x plus 4 is a factor. Negative 4 is a root or 0. So I am at degree 3. This gets dropped 1 degree down, so now these are the coefficients of the degree lower. Squared, minus 4x, positive 2. So my answer to this division problem would be x squared minus 4x plus 2. I could ask you things like this. Find all roots of 3x cubed minus 4x squared minus 28x minus 16 if x plus 2 is a factor. Well, knowing that x plus 2 is a factor, you immediately know that one of the roots would be negative 2. Set that to 0 and solve that, so you could immediately jump to one of those answers. So knowing that negative 2 is a root or a 0, you can take it and stick it on the outside, and we should end up with a remainder of 0. Descending order, exponents 3, 2, 1, 0. Great, we don't need to fill in any missing terms. 3, negative 4, negative 28, negative 16. Let's bring down my first term of 3, multiply. 3 times negative 2, negative 6, add down. Multiply. 20, add down. Multiply. Add down. Great, it is a remainder of 0, just as it should be, knowing that it is a factor. So when you divide this by x plus 2, what you get left is dropped a degree, 2 squared, minus 10x, minus 8. So now what we have left over is 3x squared minus 10x minus 8. Knowing that if we multiply that times x plus 2, we are going to be back to my original polynomial. There you go. And I asked for all the roots. Well, I know one root is negative 2. This right here can be factored a little bit further. We could factor this right here to 3x plus 2, yes, 3x plus 2 times x minus 4. Let's double check that. 3x squared for my front. My back would be negative 8. And my middle term is found with the outside, negative 12, and my inside, positive 2. Great, that gives me negative 10. And then I can bring this factor down, x plus 2 equals all this. Wow. So now we have factored, really, this third degree polynomial. But now we need to find the roots. So set each one to 0. And solve. Subtract 2, divide by 3, x equals negative 2/3. Add 4, subtract 2. Those are our roots and our zeros. Let's take a look at another one of those. Taking synthetic division and using it as a tool. say find all roots. So find all roots of x cubed minus x squared minus 22x plus 40 if x equals 4 is a root. Here is slightly different from the previous problem. I have now given you the root. I didn't give you the factor that you need to change, so we can take this root immediately and put it on the outside of my synthetic division problem. Coefficients, it is in descending order, 3, 2, 1, 0, so I can just grab those coefficients, 1, -1, -22, and a positive 40. First term comes down, multiply. Add down, multiply. Add down, multiply. Add down, remainder of 0, it is a root, we have now shown that, so take my third degree and drop it down a degree, squared, positive 3x, -10. So now, what we're looking at is you have x squared plus 3x minus 10 times my secondary factor, not of x equals 4, but the factor. So imagine subtracting 4 to get everything on the same side as that x. You would have x minus 4 equals this, my original polynomial. Well, you can take a look at this. You can ask yourself, well, can this be factored? And hopefully you're saying yes. Let's see, x plus 5, x minus 2. Bringing down this factor of x minus 4 equals that whole third degree polynomial. Well, we are asked for the roots. These are factors, so set each factor to 0 and solve. So this would give us x equals -5, x equals positive 2, and x equals positive 4. Those would be your 3 roots. I hope that helps. I will see you next time. Have a great day.